All right, here we go with section 3.2. Again, we're going to do this over multiple days. And I'm not going to make you upload anything this day, but I'm going to tell you how much you should have done. And then we will finish it up and turn it in the next day. So here are the goals that we're dealing with. Things you want to be able to do: evaluate linear function and write linear functions. And then actually on Friday we'll do more of the application stuff, solving applications. So one thing that's different that we'll be using is something called function notation. And this is something that tends to confuse people, but it's really not that difficult once you see it a few times. Okay, so function notation is a method for writing variables as a function of other variables. What does that mean? For example, the variable y becomes f of x. So we're just switching them, meaning that x is used to find y. So just another way to write it. So instead of writing y equals 3x plus 5, we would say that the function of x, or f of x, equals 3x plus 5. So if I wanted to, if x was equal to, if we want to find when x is equal to 4, then we would write it as f of 4. And then we would do 3 times 4 plus 5. And we get an answer of f of 4 equals 12 plus 5. You get 17. So and that's what would tell us that when you evaluate this function at 4, you get an output of 17, which really over here, this becomes what your traditional y would be over there. Okay? And a couple other things is we're going to deal with linear functions. I always look at the root word here. Linear means line. And that tells us right here, a function whose graph is a line. Linear functions have a constant rate of change, slope. And we've talked about some equations from last chapter. So this is where, if you struggled with some of these equations last chapter, here they are again, so another chance to learn them. Y equals mx plus b is our slope-intercept form. And then we have point-slope form. So this is slope-intercept form, this is our point-slope form, and we won't do this one much, but a standard form. You can also do it with a table of values and a graph. So some examples. Notice here you can call it whatever you want, f of x, g of x, h of x, it doesn't matter, but they want us to evaluate when x equals 4. So I want you to show your work. This is good practice, good mental math. And same thing on your homework, I want you to show your work. So in this case, f of 4 equals 2 times 4 minus 5. So that's 8 minus 5. So f of 4 equals 3. So again, show me all those steps. If I come over here, if I do g of 4, I get 3 minus 7 times 4, which is 3 minus 28. 3 minus 28 equals a negative 25. And last one here in this section, h of 4 was 1/2, not fourth. There's my 4. Plus 5. H of 4 again. Half of 4 is 2. So you get h of 4 equals 7. Couple more questions with the same thing. So my f of 5 equals 2 times 5 plus 1 minus 4. Gotta be a little bit careful with order of operations. So we need to do our what's inside parentheses first. So you have 2 times 6 minus 4. So that's 12 minus 4, which is 8. So I evaluated f of 5, wrote it out using function notation because that's what it says right here in the directions. And then another one says f of negative 1. So that equals 2 times, this becomes negative 1. Oops, my daughter's sight words from kindergarten. Negative 1 plus 1, which is just going to be 0. So since that's 0, we have 2 times 0 minus 4. 0 minus 4. So we just end up at negative 4. We'll carry down our function notation here. So we evaluated these using function notation for f of 5 and f of negative 1. All right, now we're going to move on to getting closer to some story problems. Right now we're just going to focus on just using a table. And we're going to write a linear function for it. The easiest way to solve these when there is not a 0 is to use point-slope form. If there's a 0, then you could use slope-intercept form because that would give you the y-intercept. Of course, sometimes you could work backwards. This one's pretty easy to work backwards because you're decreasing by 6.5 and we're by 0. So 4, 3, 2, 1, 0. And since we're going down by 6.5 here, our actual point ends up being 0, 0. So one way to do this, we know that we're going our rise, our change in y is 6.5 over 1. So our change in y over change in x equals 6.5. I just did that. 6.5. So that's my slope. I still have some kids on tests when we're writing this. They'll do the following. And I've said this over and over and over again. They write m. We know what m is. It's 6.5. So write your 6.5. 6.5x plus, what's my y-intercept? Well, it happens to be 0 in this case. So y equals 6.5x. That was using slope-intercept form. You can also do point-slope form. It's just as easy. So if we did a x1 and a y1, so you would have y minus y1, which is 6.5. It's equal to my slope, also 6.5, x minus x1. Well, my x1 is 1, so we have x minus 1. So real quick, when we do our distributive property, I get 6.5x minus 6.5. Well, look what happens. When I add my 6.5, then that cancels. And guess what I get? Same thing. So if you can figure out your 0, you can do this way. But the tried and true way that will always work is your point-slope form, which is what I'll continue to do. So over here, my change in y over change in x is equal to my slope, which is equal to, we're going up 3 and 1. So 3 over 1, my slope's 3. I'm going to pick a really easy point, x1, y1. And these are pretty typical of what you're going to see throughout this chapter. We don't make the numbers very difficult. So y minus 1 equals my slope, which we said was 3, x minus 1. So that's our point slope form. Do a quick distributive property. Y minus 1 equals 3x minus 3. Add 1 to both sides. And y equals 3x minus 2. And this is our last one that we're doing for today. This is the cost to make 4 bracelets. So this is kind of a story problem as shown on the table. How can you determine the cost to make any number of bracelets? Well, it's easy. You put it into an equation. So we do this right here. We have a slope of 15 over 1. We went up 15, we went up 1. So that's my change in y. That's my change in x. That's my slope. So we do x1 and y1 because we're doing a point slope form. Y minus 17 equals my slope, which is 15 times x minus 1. So that's 15x minus 15. This drops down. Add 17. Add 17. Y equals 15x plus 2. So how can you determine the cost? There's a formula you can use. And the reason I want these to go into slope-intercept form, because now if they were to say, what if you sell 10 bracelets? It's really easy. You would do 15 times 10 and then add 2. The cost would be $152. And it's also good practice for your final exam that's coming up here. So now you're jumping to 3.2 practice. Eventually we're going to do all this, but hold off on doing the next pages because I want you to make sure that you're following my directions. Notice there's 2 of these that you have to do, and you have to show work, evaluate for x equals -1 and x equals 3. So we have to do, we're in the practice section, and we're going to do 1 through 12. That is it for the first part of this assignment. More to come on the second day tomorrow. Have a good one.